Here we will look at an example that has to do with determining symmetries algebraically. I would only do this if the question specifically asked to determine a symmetry algebraically. For this, to determine if a relation is symmetric about the x-axis, you are going to replace y with negative y. So let's do that first. Also, we need to make a note that whatever you're given in your problem, we're going to call the original. Alright, so for symmetry about the x-axis, I'm going to make myself a note, and I'm going to say that anywhere there's a y, replace that with negative y. So go into the original equation, and anywhere you see a y, put negative y. So you'd have negative y squared plus 3x cubed equals 7. Notice that I put my negative y in parentheses. It's always a good idea. Now, remember something that you know about powers, and I'm going to state both of the things that you know so that as you need them throughout this example, you can use them. Anytime you have a negative raised to an even power, it becomes positive. Anytime you have a negative raised to an odd power, it stays negative. So in this particular case, we see that we have a negative value raised to an even power, so negative y raised to the second would become positive y to the second. And then the plus 3x cubed and the equals 7 would remain the same. Now, what you want to do is you want to compare this result to the original. So is this the same as what we originally had? If the answer is yes, then we would say that this function is symmetric about the x-axis. So we will say here that it does indeed match the original. And so we would say that it is symmetric about the x-axis. Okay, now go on to the next part. Next part says to determine if a relation is symmetric about the y-axis, replace x with negative x. So here, symmetric about the y-axis, I will make myself a note that I need to replace x with negative x. Okay, I'm going to copy down my original right here above so that I always have that to look at. So the original was y squared plus 3x cubed equals 7. So in that expression where x was, I'm going to put a negative x. So we'd have y squared plus 3, and then open parentheses, negative x cubed equals 7. To simplify, y squared would just stay. And then here we have a negative x that's cubed. Well, we know because the power is odd, then it's going to stay negative. And actually what I will do is I will place the negative sign out in front of the 3 so that we don't have too many signs and symbols here. Alright, now we need to see if this matches the original. So we need to go back and compare here. It does not match the original because of the negative sign here. So does not match. And so you would say is not symmetric about the y-axis. Okay, and then finally, as our third piece, to determine if a relation is symmetric about the origin, replace both x with negative x and y with negative y. So coming back down, we have this one, symmetry about the origin. Okay, I'm going to make myself a note that y needs to be replaced with negative y and x needs to be replaced with negative x. Okay, I'll copy down my original function right here above just so it's easy for me to see what I'm comparing it to and where I need to substitute in values. So here, replacing both, I would have negative y squared plus 3 times negative x cubed equals 7. Simplifying, I know when I square a negative, it would become positive. So this would be positive y squared. Next, I know when I cube a negative, it would stay negative. So I'll rewrite this and it would become negative 3x to the third equals 7. I then want to compare this to the original here. I notice that it's not the same, so it does not match. And so I would say it is not symmetric about the origin. Okay, I'm also going to come back and I'm going to look at what I found and then talk about if the function is even, odd, or neither. Symmetry about the x-axis has no special name. Symmetry about the y-axis, if it is, it's even. Because it was not symmetric about the y-axis, then we're going to say that it's not even. And then coming down, symmetry about the origin, we found out that it was not symmetric about the origin, and so we would say that it is not odd as well. And so here we would say it would be neither even nor odd.